Okay, guys. Any questions on 1 through 8? Yes, Abby?
Number 7.
Number 7. Okay. Did you have any problems with the first line? Did you break down the 75 to 25 and 3?
Yeah.
The 28 to 4 and 7? The 50 to 25 and 2? And the 63 to 9 and 7?
Yeah.
So we got that. All right. So the second line, when you took the square root of 25 and pulled out the 5, did you multiply it by the 2 and get 10 root 3?
Yes.
Okay. And then did you get negative 6 root 7?
Yes.
And then 5 root 2?
Mm-hmm.
And then negative 3 root 7?
Yes.
Okay. Last step is to combine just the things that are alike. We have 3 roots. We have root 2, root 3, and root 7. The only thing that there's more than one of is the root 7. So the other stuff we just have to list. 5 plus 10 root 3 minus. Then you combine the 2 root 7s. Negative 6 and negative 3 is negative 9 roots of 7. Make sense? Okay, Truva?
Number 8.
Number 8. All right, so what we're going to do is we're going to distribute. 3 times 4 is 12. 3 times 2 is 6. Can't go inside the radicals. Integers with integers, radicals with radicals. Okay, so, now I have a radical times an integer. So I just write negative 3 root 5. And now I do negative root 5 times square root of 5 is negative square root of 25, which is 5. So then you combine the 12 and the negative 5 to give you the 7. And negative 6 root 5 minus 3 root 5 is negative 9 roots of 5. All right. Anything else? Okay. The second part. The second part was going back to review of finding equations for lines that were either parallel or perpendicular. You tell me. If it is parallel, what kind of slopes do they have? The same slope. So you find the slope of the line they give you and use the same slope. If it's perpendicular, what kind of slopes are they? Opposite sign and reciprocal. So we find the slope of the original equation, change the sign of it, and flip it. Okay? So take a look at these and see if you have questions. Nathan, did that help any? We just talked about what to do there. Awesome.
The first one?
Yes.
The y intercept?
Okay. Did you write it as negative 7.5? No.
I got negative 3 over 2.
Negative 3 over 2.
6 over 4.
Yeah, 6 over 4, that's what it was.
Did y'all not? That's what I got too.
Oh, 6 over 4? It should have been...
They didn't simplify.
There was 18 over 2.
Did you subtract the 3 or did you add the 3?
Wait, why don't
I thought this
you
side
replace?
has to equal the y, so I added, I think.
To move this 3 over, we had to subtract it.
Oh, we added. Okay.
Right, you have to subtract it. Okay, so parallel, we just look at the line we're given. Okay, now what was our shortcut yesterday? You do the opposite of A over B. So the slope of this line is negative 3 over negative 6, which is positive 1/2. And because it's a parallel line, we're going to use the same one. If it's perpendicular, we find a slope, and then the slope we use is the opposite sign and reciprocal. Plugging them into point slope. Y minus y1 equals m times x minus x1. Okay? Yes, sir?
So we don't when it tells you the point, you don't plug it in for y and x, because that's what my 8th grade teacher told me we have to do.
When it gives you the point, you are plugging it in for y1 and x1.
So we do point slope.
Uh-huh. Oh, you plugged it into slope intercept and found B, didn't you?
Yeah. So
That is another totally acceptable way of doing it.
okay.
All right. Okay, let's look at today's stuff. what we're going to do today is we're going to revisit distance and midpoint. Okay, you've seen both of these, but it may have been a while. So let's go back over the distance between given points. It says find the distance between the given points by plotting the points and using the Pythagorean theorem. Who remembers the Pythagorean theorem?
A squared plus B squared equals C squared.
Okay, a squared plus b squared equals c squared. What do a and b represent?
The two sides.
The two legs. The two legs of a right triangle. What does c represent?
Hypotenuse.
Good. All right. Now, do you see that my points are different than the points that are on your page? Yeah, because when I threw a graph on there, I didn't bother to count, and the points I gave you on your graph don't fit on my. Anyway, so change the points to what I have. Change the points to what I have and go ahead and plot these. Okay, do you have the 2 points plotted?
Yes.
All right, now what we're going to do is form a right triangle out of this so that we can use the Pythagorean theorem. So the way we would do this is we would do the horizontal distance from this point to this point. So I'm going to draw a line that goes the horizontal distance from here to here. And then the vertical distance from there up. And then the distance that I want ends up being the hypotenuse of that right triangle. And that's how we can apply the Pythagorean theorem to find the distance. Does that make sense? All right, when it's on a grid like this, we can just count. What is the distance? Count the blocks from here to here. What is that? 6. Count the blocks from here to here. What is that?
8.
8. So we're going to say that a squared plus b squared, 6 squared plus 8 squared, is going to equal that c squared, which in our case is that distance. So can I use d?
36.
All right. So we get 36 plus 64 equals d squared. So 100 equals d squared. Now we're taking the square root of both sides because that's how we undo a square. Now generally, when you take the square root, you get a positive and a negative number. But why do I only write the positive here?
Because it's
Because distance is positive. Thank you. So the distance between these 2 points is 10 units. Okay. Now, let's say I didn't give you exact points. I gave you any 2 points. So let's call this one over here x1, y1, and let's call this one up here x2, y2. So in general, what can I do to find that horizontal and vertical distance if I'm not given specific points? What could represent that horizontal distance? How can I find that?
Is it X1, Y2? Or X1, X2?
What are we going to do with the x1 and x2?
Minus x.
We're going to subtract the x's. Subtract the x's gives us the distance here, doesn't it?
Oh.
And subtract the y's will give us that vertical distance, won't it? So, in general, given any 2 points, this horizontal distance is represented by x2 minus x1. That's our horizontal distance. And the vertical distance is described as y2 minus y1. So these are the legs of that right triangle. So if I take those differences and square them, which does 2 nice things. Sometimes when I subtract, I might get out a negative number. But is distance ever negative?
No.
But when I square anything, what happens to it? It becomes positive. So that square takes care of ever getting out a negative number for distance. So that is equal to this c squared, which in our case is d squared. So to solve, we're just saying the square root of the difference in your x's squared plus the difference in your y squared. And this is the distance formula. We can use this formula to find the distance between any 2 points, whether or not we have a coordinate plane.
I remember.
It's ringing a bell, isn't it? Good. Good.
We like started at the end of the year.
Oh, okay.
Yeah.
Yes.
But if it was going to be squared, why do we have it to the second power? Or if it's going to be...
If we're going to take the square root of it?
Yes.
Well, because that's what we have to do to solve the Pythagorean theorem, don't we? The last step is to take the square root of both sides. So that's what we had to do here also, because that's what we're using, the concepts of the Pythagorean theorem. All right, now, even though we have this groovy distance formula, sometimes it's overkill. Like if we notice something like this, we have the point negative 3, 2 and the point 4, 2. So negative 3, 2 and 4, 2. I don't need to use the distance formula, do I?
No.
Because these values are the same. So the distance between these points is just the difference between those. 7. Now, we do need to take the absolute value of it here, because nobody tells us this is first point, this is second point. What if we called this first point, this second point? We'd end up with a negative distance. So do you see how here it says, take the absolute value of the difference? So whenever you have the same y's, you can do that and get the distance is the difference in your x's, which in this case is 7. All right? Now this one we have the same x's. So we have one at 2, 5 and one at 2, negative 3. So it's the same idea. The distance between here is just the absolute value of the difference in your y's. If I took the second one minus the first one, the distance is 8 units. Okay. So even though distance formula is fabulous, if you notice something like this, if you go, ooh, same y's, just subtract my x's. Same x's, just subtract my y's. It's a little quicker. Okay, yes?
Do they have to be the same?
They have to be the same, otherwise you have to use the distance formula. If you don't have the same x's or the same y's, then we got to go back to the whole distance formula. So let's work through one problem just using the distance formula. Let's say we had the point 3, negative 2, negative 3, negative 2, and positive 2, positive 4. And we're going to find the distance between them using the distance formula. So it's the square root of the difference in your x's. So 2 minus negative 3 squared plus the difference in your y's. 4 minus negative 2 squared. So the distance is, help me out here, guys.
Oh, it's 5.
5 squared, good, plus 6 squared. What is 5 squared? 25. Plus 6 squared is 36. So the exact distance is the square root of 61. Now, what would the approximate distance be?
8.
It's close to 8. Can you punch it in and see what it's even closer to?
I know we weren't supposed to use a calculator.
She's told.
I'm letting you right now.
Oh. I'm just saying. She said yeah.
61.
Square root of 61.
That's what I put in.
You forgot the square root, maybe.
No, I did it too. It's
What'd you get?
the same thing.
It just shows it.
Okay, hit the little arrows going opposite ways button. And
7.81.
7.81. Okay.
What do you do?
On your calculator, right now the enter button is 2 arrows that point opposite ways. If you want to convert That's how you do it.
I can practice.
Hit that button.
That's weird.
Like where?
What is
That's cool.
Well, your screen just
Maybe
like
someone on the roof?
Somebody's in there.
Sounds like someone hammering up on the roof. Okay. All right. Any questions? Okay, you try this example here, please. I want the exact and the approximate. Justin, these directions are for you. You try. There we go.
Maybe you feel good.
Wait, which area was it again?
It's not like this.
Yeah, it is.
Like this.
Should put it.
Made you feel good. So
I'm gonna put this where?
Syntax here.
Yeah, it's just.
I got big hits.
Mine's just syntax there.
You didn't get an approximate? I got 6.40.
Yeah.
Okay, so for my exact, I got square root of 41. And for the approximate, I got 6.40.
Do you have to put the 0?
If I ask you to round it to the nearest hundredth, you should. Okay, are we okay with distance?
Yeah.
All right, let's look at distance one more way, and this is interesting here. Some of you may already notice that the x's are the same, so you know what to do. But I want to still use the distance formula on this one just to show what happens when the x's are not the same, okay? So even though the x's are, find the y coordinate if the distance between 4, -2 and 4y is 6 units. I know that's not what your directions say. Your directions had extra words in it, and they didn't make any
Find the y
sense.
coordinate distance between.
Yeah, I know. I know what your directions say. They don't make any sense. So I fixed it. Okay? So find the y coordinate if the distance between these 2 points is 6 units. So we know we're dealing with distance, so we're using distance formula on the coordinate plane. Oh, thank you. Getting ahead of myself. All right, so we'll fill in what we do know. We know the distance is 6. So 6 equals the root of the difference in our x's, so 4 minus 4 squared, and the difference in our y's, y minus -2 squared. Okay, now the nice part for us is this gives us 0. So we don't even really have to think about it. So what we have, 6 equals the square root of y plus 2 squared. Now, we want to get in here so we can solve for y. And several of you may already know the answer just by looking at it. But to get in here to solve for y, we can square both sides. And we get 36 equals y plus 2 squared. And then take the square root of both sides to make this go away. But when I take the square root of 36, I get positive and -6. Which tells us there are 2 possible y values that would make this work. Yep. So we do 6 minus 2 is y, or -6 minus 2 is another option for y. So our choices are 4 or negative 8 are the two y values that would make this work. And you can put that out and take a look at it. So if we had a point 1, 2, 3, 4, negative 2. So we could either have a point at 4, positive 4 up here, or 4, negative 8 down here, and they're both the same distance of 6, aren't they?
Yeah.
So there are two possibles. Okay? All right. Midpoint. The midpoint of a line drawn between the points x1, y1, and x2, y2 is given by this formula. So the midpoint is the point on the line that divides the segment into two congruent segments. So you average your x's and you average your y to get that midpoint. This is simple. So if we have the endpoints 2, 5, and negative 4, negative 7, you add up your x's, divide by 2. Add up your y's, divide by 2. That's all there is to it. Add them up, divide by 2. So we get negative 2 over 2 is negative 1. Negative 2 over 2 is negative 1. Before somebody asks, we don't always get the same number. It just happened on my example. Okay? We can get decimals. We can leave them as fractions. We usually don't get the same number, just in this particular example you did. All right, now this one's a little more interesting. What's wrong? Oh, okay. The next one gave you one endpoint and a midpoint and asked you to find the other endpoint. So if I think about the formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. If I think about this formula, when I add up my x's and divide by 2, don't I get the x at the midpoint? So I know one of my x's is 2. I don't know the other. But I know when I divide by 2, I get the x at the midpoint. When you add up your x's and divide by 2, you get the x at the midpoint.
Charles, you leaving?
Hello?
Put up your calculator. Oh, your wishes, my
I sure do. I'd be happy to, thank you.
Bye, Charles.
Good luck. I hope you have a great tournament. And by that, I mean beat everybody badly. All right, so to solve this, we multiply by 2, and we get x equals negative 10. So that's our x value. You try to find the y value now.
Is the homework the little sheet?
The homework is the little sheet, and the rest of you can watch the end of the video online if you have the time. Okay, so what I did was, I knew when I add up my x's and divide by 2, I should get the x value at the midpoint. So I added up the x I knew with the one I don't know, but when I divide it by 2, I get the x value at the midpoint. So now I'm going to add the y value with the one I don't know, but when I divide it by 2, I should get my y at the midpoint.
How does 2 divide by 2 equal negative 4? Do you have to multiply by
I didn't divide by 2. I multiplied both sides by 2 to get it out the bottom.
Boom.
Alright.
Oh, you're taking
No.
yourself.
Okay, so on the next one for the y, one of the y values we know is 5. We do not know the other one. But we know that when we average them, we get the y value at the midpoint. So we solve this equation. The easiest way to solve this equation is to get rid of the denominator. The way you get rid of the denominator is to multiply both sides by that denominator. So we get 5 plus y equals negative 14, so y equals negative 19. So what is the other endpoint? Negative 10, negative 19. Make sense?
Yeah.
That makes a whole lot of sense.
Good.
You went really fast. And I was like,
I've been finding midpoints for 30 years. So sometimes I don't go slow enough. Okay. All right, what I want you to look at is this real quick, because I could tell from the warm-ups, and I already knew from last period, that we need a refresher on our quadrilaterals. Okay, a quadrilateral is a polygon with
4 sides.
4 sides. We have a family of special quadrilaterals. The special quadrilaterals that we're going to talk about, first is the parallelogram family, and then we'll talk about the trapezoids and the kite.
Here, that was square. That wasn't square. Or was it?
Because I had to get rid of that too. So I took a square root and get rid of that too.
You better write that stuff down, man.
Okay, so let's talk about the parallelogram family. And after that, I'm going to give you enough time to mark the picture. So go ahead and label the top one, parallelogram. Okay, parallelogram is a special quadrilateral that has 2 pair of parallel sides. So I marked them. 1 arrow, 1 arrow. That shows these sides are parallel. 2 arrows, 2 arrows. That shows the other sides are parallel. Now, there are a lot of special things about a parallelogram. On a parallelogram, opposite sides are congruent, which is why we got 1 tick, 1 tick. 2 ticks, 2 ticks. Opposite sides are congruent on a parallelogram. Opposite angles are congruent. So that's why we got 1 angle mark, 1 angle mark. 2 angle marks, 2 angle marks. Okay, and the diagonals of a parallelogram bisect each other. So I changed the color instead of putting 3 and 4 tick marks. This diagonal is bisected where the other diagonal intersects it. So this segment is congruent to this segment. This diagonal is also bisected. So this segment is congruent to that segment. So all those things about a parallelogram. The biggie is we have 2 pair of parallel sides. The top and bottom are parallel, and the left side and right side are parallel. 2 pair of parallel sides. Now, the other polygons that are in this family are the rectangle, rhombus, and the square. Everything that is true about the parallelogram is true about the rectangle, the rhombus, and the square. All of this stuff is true for each one of these. But in addition to that, the rectangle has 4 right angles. So all of this is true plus 4 right angles. And where the diagonals intersect, it bisects those diagonals into 4 congruent parts. Each little segment is congruent from the intersection. Yeah? So this point right here would be the midpoint of that diagonal, wouldn't it? The intersection point is the midpoint of each of those diagonals. Okay, so that's rectangle. All right, rhombus. Everything that's true about the parallelogram is also true about the rhombus. And in addition to that, instead of just the opposite sides being congruent, all 4 sides are congruent. And where the diagonals intersect, it forms a right angle. They are perpendicular. And the last one is a square. And everything that's true about the parallelogram and the rectangle and the rhombus is true about the square. So everything from either of the others is true about the square. Yes, ma'am?
Are all the angles on the parallelogram the same?
No. Opposite angles are the same. So if this, let's just just say this was 40 degrees. This would also be 40 degrees. And this one would be 140, and that would be 140. Consecutive angles are supplementary. Because of the stuff you learned about parallel lines last year. Lines cut by transversal. Okay. All right. Now, trapezoid. Trapezoid has how many parallel sides? One pair. Yeah, two of them. One pair. This one had two pairs. Trapezoid only one. Isosceles trapezoid has one pair of parallel lines, and the other two lines are congruent. That's what makes it isosceles. And the diagonals are also congruent on the isosceles. The diagonals will not be congruent on just a regular trapezoid. And then the last one looks like a kite, and it is called a kite. And instead of opposite sides being congruent, consecutive. The two that are together, consecutive sides are congruent. So these two sides have the same length, and these two sides have the same length. And their diagonals are perpendicular. So, now that we refreshed ourselves on all the stuff about them, let's go back and see, what do we need? No, wrong button. Boo. Boo. Okay. There we go, right button. Okay, the first one is the rectangle. Well, the rectangle has 4 right angles. So we need to know we have 4 right angles and 2 pairs of parallel lines. 4 right angles do it. Yes. The only way you can have 4 right angles is if you do have parallel lines. So if we knew 4 right angles, we're good. So we don't even have to have that. If we just knew 2 pairs of parallel lines, that's just parallelogram. That's not rectangle. Okay, so 4 right angles, how do we tell with what we've learned in this unit? Right angle is perpendicular line. Perpendicular line, slopes are opposite reciprocal. You can't even tell what that says. It looked like up. Opposite reciprocal for your slope. There we go. Is that a little better? It's me abbreviating, but.
What is that above the line?
You don't like the way I right angle? There we go. Does that make you happier? You can put the little through it. Okay, rhombus. 4 congruent sides. What do we use to find congruence? Same distance, right? Distance formula. You know what, I'm just going to let you copy at your own pace. Square. We need 2 things. We need to know congruent sides and right angles. So we're going to use distance and opposite reciprocals for our slope. Trapezoid, 1 pair of parallel lines. Same slope. Isosceles trap. 1 pair of parallel, that didn't look like parallel. There we go. Parallel lines. And then the other segments need to be congruent. So we need distance formula. This word is same. Still doesn't look like same. There we go. Okay, is this refreshing information for you, or is some of this feel like brand new information?
Well,
Some of it's new, but most of it you've heard before?
It's all the
Okay.
same, just different ways of saying it.
Okay.
This is more advanced.
All right, are y'all ready for me to flip to the last couple?
No. Almost done.
Okay. All right, here comes the last few, and these are a little easy. Oh,
We can go
Oh.
online.
oh, your homework
Oh no.
is just the front side of the little half sheet. Just the front of the little half sheet. Just the, yeah. If you put it in your notebook, the way you put it in, you can see what's in the front. The front has a spot for your name.
Yeah.
Just the front. We'll do the chart together.
Miss Burley, what if I was at the very beginning of my science class, but pulled out right then, but missed all my fitness class? Do I need to show it to my fitness?
You know what? Everybody look it up online. You're really supposed to give it to me because you came into my class, but everybody else can see it on the computer. Thank you, Jacob.